Hello friends, I am Professor Shubham Shedge from Department of Mathematics, SM Joshi College, Hadapsar. I delivered a lecture on calculus of several variables of BSc second first paper. So, before starting this paper, I will introduce a syllabus. We have four units. First is limit and continuity. Second one is partial derivative and differentiability. Third is extreme values. And fourth one is a multiple integrals. Multiple integrals. So, we will go into first chapter, limit and continuity. In a limit and continuity, we discuss the function of several variables, function of two variables, domain and range, graphs, function of three or more variables, and second is limit and continuity. In a ninth standard, sorry, in a 11th standard, we discuss the set, relation, function, one function, onto function, and domain of function, codomain of function, range of function. We are studying in a 11th standard, and also limit and continuity is studied in a 11th and 12th standard. But in SYBSc syllabus, we are studying the material of limit and continuity in epsilon delta. That is, solve the example by epsilon delta. So, firstly, we get preliminaries, that is introduction of sets, relations, and functions. What is the definition of set? We are we get a basics of limit and continuity and functions of several variables. So before starting the syllabus, we discuss the basic of the mathematics. Is a first is a set. In a ninth standard, we are studying the set. That is, what is the definition of set? Set means that a collection of well-defined object is called as a set. For example, weeks, days in a weeks, that is Sunday, Monday, Tuesday, Thursday, Wednesday, Friday, Saturday are the weeks in a are the days in a week. They forms a set. Set means that collection of objects, but they are well defined. That is, collection of well defined objects is called as a set. This definition are studied in 9th standard, also in a 11th standard. Next is a Cartesian product. Before starting the Cartesian product, sets, properties of sets. Sets can be denoted by capital letters A, and elements of sets are denoted by small letters A, B, C. That is, capital A means that it is denoted by capital letter, set is denoted by capital letter, and elements are denoted by small letters. And next point is a Cartesian product. Let A and B are sets, then Cartesian product Cartesian product Cartesian product of a set A and B is denoted by A cross B and defined as A cross B is equal to set containing ordered pair AB such that first element belongs to the first set, that is small a belongs to capital A and small b belongs to capital A. This is also studied in ninth standard. What is the definition of Cartesian product? Let A and B are two sets, then Cartesian product of A and B is denoted by A cross B and defined as A cross B is equal to ordered pair AB. It means that collection of all ordered pairs such that first element belonging to A and second element belonging to B is called as Cartesian product of A and B. For example, we see if if A is equal to 1 2 and 3, and B is equal to A comma B, then A cross B is equal to set containing 1A comma 1B comma 2A comma 2B comma 3A comma 3. Therefore, Cartesian product of A cross B is the first element in a first set and second element in a second set. It's called as Cartesian product. Now, we will discuss the next definition is a relation. First is set, second is a Cartesian product, third is a relation. What is the definition of relation? Relation means A is A and B are non-empty sets, then R is a subset of A cross B. If R is any subset of A cross B, then R is called as a relation from A to B. Then R is called relation from A to B. It means that any subset of A cross B is called as a relation. जे A क्रॉस B चा कोणताही सबसेट घेतला तर तो काय फॉर्म करतोय रिलेशन फॉर्म करतो कुठून A पासून B पर्यंत. It's called as relation. Okay. For example, we see if A is equal to 1, 2, 3. B is equal to A, B, and R is equal to set containing order pair 1A, 2B, 2C, 3A. Okay. Then here we see that R is a subset of A cross B, because here A cross B is equal to 1A, 1B, 2A, 2B, 3A, 3. Here we see that all the elements of R are also the element of A cross B. Therefore, R is a subset of A cross B. And R is a subset of A cross B. Therefore, R is a relation from A to B. R is a relation from A to B. And it is also denoted by a Venn diagram. That is 1, 2, 3. It is A set. Here is a B set. That is A and B. Here 1 goes to 1, A, 2 goes to B, 2 goes to H, okay, 2 goes to B, 2 goes to A, 3 goes to A. Here we have to find domain, codomain, and range. Simply the elements which has image. Here we change the example. 3A is cancelled for improving our knowledge. So domain of a relation means that element in A, that is in a first set, has image is called as domain. Therefore, here domain of Here 1 has image, so 1. 2 has image, so 2. 3 has no image, so domain of this relation is 1 and 2. Now we see range of relation. Range of R means the elements in a B which has pre-image in a A. That is, if one has image A, then A has pre-image 1. So here A and B both has pre-image in a domain. So range of R is equal to A and B. This is the basic of relation. You got? For additional knowledge, please see the 11th standard books of sets and relations. Now, we discuss the next point, function. What is the definition of function? This is important for our syllabus. Is function. Sets are studied, Cartesian model is also studied, relation is also studied, and function is also studied. But this is important for this chapter is a function. What is the definition of function? A function f is a relation. A function f is a relation which has unique element in a domain. Every element in a domain has unique image in a codomain. It means that f is a function, f is a relation from A to B, is said to be function is said to be function if every element in domain, that is set A, has unique image in a codomain. That is set. It means that by way diagram we see that here set A and set B, 1, 2, 3, A and B. For showing this has a function, because if 1 goes to A, 2 goes to A, and 3 is not going. So this is function, this is not a function, because here 1 has image, 2 has image, but 3 has not image in a codomain. But the definition of function said that every element in a domain, this is called as domain, this is called as a codomain. So every element in a domain has unique image in a codomain. So here we see that 1 has image, 2 has unique image, 3 has no image. So this is not a function. If 3 goes to B, then this is a function. That is 1 goes to A, 2 goes to A, and 3 goes to B is a function, because here every element in a domain has an image and it is a unique. Now, is this a function? It is not a function, because here 2 has 2 images A and B, so this is not a function. So we have another example is a hotel menu card, because in a menu card, in a left hand side we give the menus, and in a right hand side we get a price. In a menu card, each menu has a price, and it is a unique. So hotel menu card is a standard example of a function. Now we see the domain of a function. Next, domain of a function. If A is the set, B is the set, 1, 2, 3, 4, 5, 6. A, B, C, D, E. Here we see the 1 has image B, 2 has image A, 3 has image B, 4 has image E, 5 has image C, 6 has image E. Here you see every element in a domain has unique image in a codomain. That is, here 1 has image B, 2 has image A, 3 has image B, 4 has image E, 5 has image C, and 6 has image E. So A is called domain of a function f. Here this is function f. So domain of f is whole set A. Codomain of f is whole set B, and next one is a range of f. Range of f, it means that these are the elements in a codomain which are image of some element in a domain. म्हणजे कोडोमेन मधले असे एलिमेंट ते डोमेन मधल्या कोणाच तरी इमेज असतील. That is z such that z belongs to B such that f of x is equal to z for some x belongs to f. It means that a range of f is a collection of all images. Means that range of f is a collection of all images is equal to A is image of 2, so A is contained, B is also contained, C is also contained, D is not contained because D is not an image of any element, so D is not contained in the range of F. E is contained in a range of F. So range of F is A, B, C and E. D excludes because D is not image of any element in a domain. Okay, now we will see the next definition is one-on-one function. Next definition is a one-on-one function. What is the definition of one-on-one function? One-on-one function means that the definition of one-on-one function is let f is a function from A to B is said to be one-on-one if each distinct element in a domain has distinct images in a codomain. म्हणजे जर तुमचे डिस्टिंक्ट दोन एलिमेंट असतील तर त्यांचे इमेज सुद्धा काय पाहिजे डिस्टिंक्ट पाहिजे. दोन distinct elements images distinct. So we get if 1, 2 and 3, here we get A, B and C. If 1 goes to B, 2 goes to A, and if 3 goes to A, then this is 1 1, no 1 1, because here 2 and 3 are distinct elements but image is same. So distinct elements has a distinct images, then it is a 1 1. So 3 goes to A is not a 1 1 function, 3 goes to B is also not a 1 1 function, so 3 goes to C is a 1 1 function, because distinct element in a domain has distinct elements in a distinct images in a codomain. It is called as one-on-one function. Okay. Now we see onto function. What is the definition of onto function? Onto function means that every element in a codomain, has pre-image in a domain. That is, every element in a codomain is a image of some element in a domain. That is, if 1 goes to A, 2 goes to A, 3 goes to B, 4 goes to C. Here we see that D has no any preimage, therefore this function is not a onto function because D has no any preimage. If 4 goes to D, then it is an onto function? No, this is not an onto function because it is not a function. By the definition of function, every element in the domain has unique image. Here 4 has two images, so this is not a onto function. If we add this element, it goes to D, then it is a onto function because every element in a domain, sorry, codomain has a pre-image in a domain. So, and also remark is also take a remark. F is onto if and only every element in a codomain is a B is codomain. Every element in a codomain has a pre-image, and if element has a pre-image, then it goes to range of F. So codomain is equal to range of, that is F is onto if and only if range of F is equal to codomain of F. Here we see the onto function. Now we discuss the examples on its example. Let A is equal to 1, 2, 3, 4, and B is equal to A, B, C, D, E, and F of 1 is equal to A, F of 2 is equal to B, F of 3 is equal to E, F of 4 is equal to C. And we have to check this is function, one function and onto function. Verify F is function, comma one function and onto function. Firstly, we is denoted by in a Venn diagram 1, 2, 3, 4. Domain is 1, 2, 3, 4 and codomain is A, B, C, D, E. And here 1 goes to A, 2 goes to B, 3 goes to E, 4 goes to C. 4 goes to C. Here we see that every element in a domain has unique image in a codomain. Therefore, F is a function. Therefore, F is a function. Now we will check the one function. Here we see any two distinct images have distinct images, so it is 1. F is 1 because any two distinct elements in a domain has distinct images in a codomain. So this is a one function. Now we see this is onto or not. Here we see A has pre-image, B has pre-image, C has also pre-image, D has no any pre-image. Therefore, every element in a codomain has no pre-image because here D has no pre-image. Therefore, F is onto or not onto? F is not onto. Okay, thank you. From our next lecture, we will start the syllabus of SYBSc, that is limit and continuity. First point is a functions of two variables. This is a function of one variable. We will see in the next lecture function of two variables. For attending next lecture, you improve your basic knowledge about these sets, relations, functions, 1 1 on 2, and limit and continuity in 11th and 12th standard. Okay, thank you for watching this video. Thank you very much.